When PSE&G, New Jersey's largest provider of gas and electric service, needed to build a record-breaking electrical circuit under the Newark Bay, they chose MFS Consulting Engineers.
This project is one of a kind.
It consists of 2 circuits passing under the Newark Bay
To transfer electrical conduit from one side to the other.
It's roughly about 7,000 feet across the bay.
It's actually going to set several world records.
It's 6,600 linear feet horizontal directional drilling beneath the Newark Bay from Elizabeth, New Jersey to Bayonne, New Jersey. The purpose of it is to house a new circuit from North Avenue substation to Bayonne substation.
I did quite extensive surveys. We used a combination of GPS and robotic total stations. We put a sub-consultant out to perform ground penetrating radar to look for utilities underground. We used Aqua Survey, in the Bay survey, the bathymetric surveying. So we brought together a number of teams on this, and that all came together very well.
What makes this even more challenging than the traditional horizontal directional drilling project is the fact that it's an urban location. It gives us a very small footprint to work on.
Perhaps one of the more challenging parts was just being able to get access to the sites so that we could complete the survey in a timely manner. There were a couple of sites where access was delayed due to obtaining clearances, obtaining permissions from the owners.
This whole area has a lot of environmental constraints that we have to really keep in mind when we're deciding which route to choose first of all, and then finally, once the route's chosen, we really have to make sure that we're in compliance with every regulation that is applicable to that route and those sites.
We had 7 sites total, 4 on one side of the bay and 3 on the other, that we were evaluating based on various criteria to find the preferred alternative for the crossing overall.
On one side of us, just adjacent to a closed landfill, and then on the other side of us we have a wetland area. So those are 2 regulated areas that would require specific permits for disturbing each of them. On this site we have another potential wetland area that I'll be verifying today, whether it is or is not actually a regulated feature.
In New Jersey, there's a lot of contaminated sites, which is something that we have to deal with on this project, like many others. One of the sites that was being considered was actually a capped landfill. Some sites on the east side in Bayonne had deed restrictions. In the feasibility analysis, we would look at all of these alternatives, compare and contrast, and come up with the preferred alignment depending on site access and constructability, as well as overall length. There were certain electric requirements from the electrical design engineer that said, we couldn't be over X amount of feet in length or go so deep, and there were certain subsurface utilities already in place that, if we chose certain sites, we knew we'd have to go deeper, we knew we could come shallower. So all of those things were taken into consideration in eventually developing a feasibility study report, which we submitted to the client to aid in the selection process.
Our client informed us early on that timing was one of the biggest constraints in this project. A portion of this project that the environmental team has gotten involved in is the water borings, which Nick is out there conducting right now. Once we received the permit to conduct those borings, it was outlined that they don't want us conducting any work during a certain period of time due to fish migration in this area. Once we established that that was going to be a constraint, we made sure to call the drillers immediately, arrange for whatever type of shifts we needed in order to complete the borings before the allotted time was expired. Everyone's working together as a team to make sure that there's nothing that's being overlooked. We're very open with each other in terms of what potential issues could come up in the future, and that's been very helpful in making sure that we stick to our strict timeline. I feel like that's a very big advantage of a company like us that kind of does everything, where we work together as a team.
It's going to push this the exit out further, so.
It's going to require a lot of 24-hour operations and a lot of manpower to complete this within the very tight time schedule, making this project a very difficult project, not only on a construction basis, but on a schedule basis. In order to meet the client's tight design schedule needs, MFS utilized a scheduling software, which was also provided to the client on a bi-weekly basis to maintain this tight schedule and make sure we were hitting the target deadlines. If there were instances where we weren't hitting a deadline or we were going to be off, we would see it weeks in advance and readjust our staffing needs accordingly. MFS provides a high level of QA/QC, and nothing is going to leave our door until it's 100% right and the client is 100% satisfied. That's the level of QA/QC that MFS prides themselves in producing.
I'm out here doing soil borings for a subsurface investigation. My role is figuring out the quality of the rock, the depth of the rock, the soil stratum above that, to give the engineers an idea of how they want to design the alignment properly. The soil stratum overlying the rock is just to get a general representation, cross-section of what we're dealing with in the bay as a whole, but the main area of focus is really the rock layers. We're seeing three main types of rock. The two sedimentary rocks, the shale and the sandstone, are dated to late Triassic, early Jurassic in age. All the continents at one point were together, but they started rifting around 200 million years ago, and those lithified sediments are the sandstone and shales that we're seeing in these borings today. The diabase is an igneous rock, and it's formed through volcanism. At some point there was a magma intrusion. We know it was a little bit later than the sedimentary rocks that we see, because there's actually examples of the diabase cross-cutting the sandstones.
One of the large difficulties of this project has to do with the fact that there is a lot of hard rock drilling. And it's not just one type of rock, it's actually three different formations that are converging underneath the Newark Bay. This presents a very difficult drilling operation. This region not only presents an environmental concern due to cross-contamination of soils into the bedrock region, but it also can present some collapse issues when completing the actual horizontal directional drilling. That's what makes this project a very challenging project on the terms of constructing it.
I assist in figuring out our alignment and how it all works and how everything works on paper before we bring it into the field. We had to stay shallow as long as we could. We also had to have gradual drops in the alignment so that minimalized grouting issues. There had to be constant slope. There had to be a place where the grout would be filled, and understand the phasing of grouting. A gas alignment can be flat along the bottom, and an electrical cannot because of grouting issues. So that actually contributed to the shape that we came up with.
So after we determine a preliminary alignment and profile of the HDD, my team and I start doing the analysis. In any kind of HDD alignment, what we're doing is we're looking at every point of curvature and then calculating a required pullback force. This load is used for the drilling contractor in order to size up the rig and overall checking the casing material for its structural adequacy.
Most horizontal directional drill crossings consist of the pullback of just a product pipe. This project is actually a little bit different than usual. This is a sacrificial outside casing, which will then house several other conduit casings within it. These casings need to be thermally grouted in place. The two 345 kilovolt circuits will go to a depth of about 120 feet below the existing grade.
It's actually a world record grout, and it's also a world record for a 36-inch diameter casing to house electrical conduits for this length of 6,500 feet.
It's nice to know that we've been working on something that is going to benefit a huge number of people.
This, as civil engineers, is a dream.
It's not only a record-breaking project, but once it's completed, it'll also outlast most humans' lifetimes. And to say that you're part of that as a designer and as a design team as MFS is truly an honor and a pleasure.